Welcome back, everybody. The topic for this session is SSL policy. We're gonna start with an overview of this feature, and we will then take a look at individual components of the SSL policy. Then moving on, we will talk a little bit about the HTTPS decryption in kernels to finish this session with a configuration example. The default behavior of FTD, which is when there is no SSL policy configured on the unit, is to use the access control policy to handle all communication, including the encrypted traffic. But the problem with the access control policy is that on its own, it is not able to see the content of encrypted sessions. And there might be cases where we will want to do the inspection on encrypted communication to see what is inside, to use our, let's say, advanced malware protection engines, to use file inspection in general, to make some additional checks on the communication before we allow the packets to go through the device. And this is exactly where the SSL policy is going to come into play. The main application for that one is going to be to perform HTTPS decryption, which will eventually allow us to work on the clear text HTTP traffic from the SSL TLS tunnel instead of just trying to do basic inspection on encrypted flows. Okay, the other major application for this feature is to provide selective blocking of encrypted traffic. Even though technically you can block this communication in the access control policy, you have less options as what traffic you will select for this block action. With SSL policy, we will have many more options to choose from, such as different fields from the certificate, like its status, maybe the actual URL, combined with some other criteria. So this is gonna make the whole traffic matching much more flexible. Note that when you activate an SSL policy on the device, it is going to change the behavior related to encrypted traffic handling. Instead of sending the communication to the access control policy, encrypted communication, we will first send it to the SSL engine, SSL policy for evaluation. And only if the traffic is going to be allowed by the SSL policy, we will then move it to the ACP. Firepower threat defense devices support two SSL TLS decryption methods. We have what is known as known key decryption, in which case we will be looking at communication encrypted traffic destined to one of our internal devices, typically one of our HTTP servers, the HTTPS servers, I should say, because we will be looking at encrypted communication, of course. This is what we will want to decrypt. And in this case, what is going to be needed on FTD to do the decryption, to see the content sent to our server, is going to be to have the server's private key along with its certificate. So we will have a web server. I'm going to say that this is going to be web server number 1, which is configured for SSL/TLS. So this means that it listens on this HTTPS default port, for instance, default port 443, and the traffic that is sent to this server and from this server is going to be eventually encrypted. Okay, now our server is configured with a certificate which was signed by a certain CA using a private key of that CA. And now in order to decrypt the communication between the server and a certain client, we will have to install this certificate on our FTD, and we will also have to give it the private key. Of course, this key is needed to decrypt communication signed by the client in which case the client uses the public key of our server, because we know that public key encryption is decrypted using the corresponding private key. So to see the actual content of the SSL TLS handshake, FTD is supposed to have the right key. Okay, the certificate itself is also needed so that FTD knows what traffic is potentially going to be subject to this encryption, like to differentiate between the traffic sent to different internal servers. And in this case, the FTD device technically doesn't even have to be in the traffic flow. Okay, the second option for decryption is to use the resign method, which is generally meant for traffic sent to external servers, so those that we don't manage, in which case the FTD unit is supposed to be placed inline between the client and a server, so it must sit in the data plane, where the goal is going to be to replace the server certificate with the certificate of FTD and present this modified certificate to the client. Okay, which means that we will have two separate handshakes. Let's say that we will have a client device that is trying to build and negotiate a SSL TLS VPN tunnel with a web server, and web server is running HTTPS, so this is all gonna be eventually encrypted communication. Now we have our firepower threat defense unit in the middle, which means that all traffic is flowing via FTD. So what is gonna happen in the first step is that the client is gonna generate the SSL hello message to the server. But what FTD is gonna do, in this case, assuming that we wanna do the decryption, is that it will replace the original message with its own hello. So the FTD unit is gonna act as a client to the server. This is gonna be our handshake number one. Now the server is gonna reply to the FTD, where FTD will modify the reply so it appears as a server to the originating client, which is gonna make the second handshake over here. So the end result is that we will see two handshakes during this negotiation. FTD appears as a client to the server, and FTD appears as a server to the original client. And the reason for that is that FTD will try to act as a proxy. It is more of like a man-in-the-middle type of scenario, where the goal for the system is going to be to build two TLS tunnels, each of them built using its own keys associated with the FTD's certificate. Okay, so what is different from this first case, from the known key approach, is that FTD is going to be using its own certificate to replace the server's certificate to the client. Plus, it must always sit in line between the client and the server for this decryption to be performed. Also, don't forget that the decrypted communication is always going to be subject to the access control policy inspection, because that's the goal of doing the decryption. We want to see clear text communication in the access control policy to make a better decision as whether to forward this communication, maybe inspect and forward, or basically to block it. A couple considerations related to the decryption process. In certain cases, decryption may pose a large load on the FTD unit. This, of course, depends on the amount of traffic that you will have, encrypted traffic that you will want to decrypt. And because of that, in certain cases, you will actually want to block encrypted traffic instead of decrypting it. And there are going to be few ways as how we can accomplish this. As I said previously, the actual options are much more flexible than what you could do in the access control policy. And in general, there are going to be two ways as how we can select encrypted traffic in the SSL policy. We can go for the URLs, but the problem with this approach is that in a SSL TLS session, this information, which is part of the HTTP header, is encrypted. If you think about the high-level structure of a SSL TLS protected packet, we're going to have this IP header with a source and destination. We're going to have the SSL header with a set of records. And then we're going to see this HTTP header, which contains the URI, which is going to be followed by the payload. So this stuff is encrypted. We don't see the URL in the packet. And this is going to be a problem for the appliance that is supposed to do the decryption. But even with this limitation, FTD will be able to use this information to distinguish between the different sessions. We're going to take a look at those few different options in just a moment. Now, the second main component of a SSL connection that we can also use to distinguish between the sessions is going to be the certificate itself. And of course, we are talking about the server certificate here. One of those fields you can take a look at within the certificate is going to be the status, but we have many more. We will look at those in the policy. And I would also say that the third element you could use is going to be the negotiated parameters. Parameters negotiated for the session, such as the actual version that the devices want to use to build a tunnel, or maybe the cipher suites, and also a few more. Now, going back to the URL component, the URL piece of information that we may want to use to choose the traffic to decrypt. Well, one thing that is not going to work, I can tell you that, is going to be the name resolution. Because one could think that different web servers are always hosted on different IP addresses. Like I would say IP1 for this server, then IP2 for another server. With name resolution, we could potentially try to resolve those, and this way figure out the name of the website. But this is not going to be the case, because it is possible to host multiple websites on a single IP address. So name resolution is not going to be an option. Okay, but what we can do instead is that we can take a look at the server's certificate at the common name field, or just the subject of the certificate. And this is going to work, but only in certain cases. Now, cases where it won't work are going to be those when a server is configured with a so-called wildcard certificate, which certificate can be potentially associated with multiple servers. And an example of a website where this method is not going to work is going to be Google. If we take a look at Google's certificate, we see that it is issued to something at google.com. So this is an example of a wildcard certificate, which means that there can be multiple sites that use this certificate. If we take a look at the subject, again, it's pretty much anything at google.com. And what's actually allowed to use this certificate, you will find this information, the actual websites, you will find them in the subject alternative name field, SAN. It's all Google websites, all Android websites. I think it's going to be also YouTube, which is this entry here. So if we take a look at youtube.com, check this certificate. It's the same. It's issued to something at google.com. We take a look at the subject alternative name. It's the same exact certificate. We have a single certificate that is issued by Google CA for all or most of the Google's websites. So if you take a look at the wildcard certificate information, you don't really know which website the session goes to because this certificate is hosted by multiple websites, is used by multiple websites. So this method is only going to work for sites with a dedicated certificate. Now, method number 2, which is supposed to solve a problem related to wildcard certificates, is called SNI, and this is just one of applications of SNI. The other one is going to be to allow you to distinguish between the websites hosted on a single server, on a single IP address. So with SNI, the logic is that the browser, the web client, is going to include the information about the website it is trying to connect inside of the TLS, SSL TLS hello client hello message. This is going to be one of the extensions of the TLS client hello. So this information, of course, is going to be visible since it goes in clear. This is what FTD is going to see during the negotiation, during the handshake, and we'll be able to use that for the policy rules. We have few actions that can be defined for our SSL policy rules. It doesn't necessarily have to be the decryption because, as I mentioned, the SSL policy can be also used for other purposes. The monitor action is going to be the only one intermediary action, which means that it doesn't really take effect. It doesn't affect the communication that hits the role with the monitor action configured. The purpose of this action is just to log the session and pass it on to other roles in the policy, top down. Okay, block or block with reset. This is how we can block, just drop encrypted traffic. When you block with reset, you will also terminate the underlying TCP socket. We can use don't decrypt, which is something that you would normally use to add exceptions to your SSL policy. Because in most cases, the SSL policy, most of the roles, they will be configured for decryption. That's the main application of SSL policy. Well, in some cases, you will also want to block traffic. Like, you know, it goes to encrypted malware websites. There is no point in decrypting this because you know it's bad, so you will want to block immediately. Okay, some websites you don't know what they contain, you will want to do the decryption in this case. So here we just don't know what is the status of the content. We just want to make some additional inspection in the access control policy. That's why we do the decryption in the first place. But in certain cases, there will be also websites that you will not want to decrypt. For instance, based on certain regulations, like HIPAA, or maybe you're not allowed to decrypt communications sent to financial websites. That would be an example of where you would go for the don't decrypt action. So you don't want to block, you don't want to decrypt, you just want to pass the traffic to the ACP without decrypting it. That's the purpose of the don't decrypt action. Of course, the access control policy is also going to be used for the decrypted traffic. I mentioned this a few times during this session.